Clear? So solubility of a substance is its maximum amount that can dissolve in a specified amount of solvent under specified conditions. Specified condition means that either temperature will be specified or pressure should be specified. Now, what will be the unit of solubility? Unit of solubility means, see, two things. Amount of substance. What is the unit of amount of substance? Tell. What is the unit of amount of substance? How to tell? What is the unit of amount of substance? No, amount of substance. Substance. Mole. Okay. And how much specified amount of solvent? That will be in liter. Yes or no? Mole per liter or mole per dm cube. Clear? Decimeter cube. Yes or no? Or this is known as molality also. This is known as molality also. Clear? Understood this thing? Now, solubility. Like, tell me one thing. In your home also you heard something. You saw this thing. Sometimes some solute, like you saw jaggery or many things are not dissolved in water. But if you heat it, it will dissolve. Yes or no? After heating the solvent, it will dissolve more. Okay, so if it is dissolving more, that means it is depends on temperature. Sometimes if you give pressure on it, then also sometimes it will dissolve it. Okay, and one more thing, one very important thing, that it is depend on the nature of solute and solvent. Tell me one question, that if you take sugar and salt, who will dissolve faster, sugar or salt in water? Tell. If you take water, one glass of water, and if you take one spoon of sugar and one spoon of salt, who will dissolve faster? Sugar will dissolve faster. Okay, you go. Today you go. You check. Okay, check that who will dissolve faster, sugar or salt. Instantly, who will dissolve? Understood? Obviously, salt. There is reason behind it. So the next topic is that factors affecting factors affecting solubility. Okay, factors affecting solubility. Now, which factors can affect solubility? First is nature of solute and solvent. Okay, it depends. Second is it depends on temperature. It depends on temperature. And third is it depends on pressure. Understood? So three factors are there where solubility depends. Now there are you have to understood that solubility is what is like solution is not like only liquid solution. Solution means solid in liquid also there, liquid in liquid also there, and gas in liquid also there. Yes or no? If I talk about liquid solution, we are reading liquid solution, right? So solution means solid in liquid, gas in liquid, liquid in liquid. Okay. Now liquid in liquid solubility always be there. Okay, where there are very rare liquids who will not soluble. Many liquids are not soluble, like oil and water are not soluble. Okay, but we are not talking about them. Okay, so first thing we will check solubility in solid, solubility of solid in liquid. Understood? This is the first thing we will check. Clear or not? Yes, sir. Solubility of solid in liquid. Very simple, very simple. That you take one glass of water. You take one glass of water. Okay, and you put salt in it. So this is a solubility. And this process known as, tell me, what is this process known as? Adding solid into water or soluble in water. Tell this process. I told you what is this process called. Tell. Wrong. Remember, I told you this is called dissolution. This is called dissolution, right? What is dissolution? Dissolution means when you add solute particle, in solvent. Okay. When you add solute particle in solvent, that process known as dissolution. Clear? Ajay, tell me, if I add solute particle in solvent, the concentration will increase or decrease? Concentration of solute will increase in the solvent or decrease in the solvent? Tell.
Decrease.
That may depend on the solvent also.
Why may depend on the solvent? If I have pure solvent, okay, pure solvent, I am adding salt in it. Tell me, salt concentration in the solvent will be increase or decrease? Let's suppose you have a empty room, okay, and people are entering in that room. So the concentration of people in that room increase or decrease? Increase. So that's same thing. The same thing I'm talking about here. Okay. So if you add salt or any solute in solvent, the concentration of solute will increase. Always, yes or no? Like this concentration term, you learn all the thing. This all thing will increase. Clear? Now, what is the backside process? Backside process. Solvent to solid when come back. What is that called? Solute. If I add in solvent, that is called dissolution. When from solution, solute particle coming outside, what is that called?
Crystallization.
Very good. So crystallization. So what is crystallization? Crystallization is that some solute particle, some solute particles, some solute particles in the solution collide with solute particles, solute particles, and separated out, and that process known as crystallization. I told you earlier also, like if you take a water and you put salt in it again and again, what will happen after some time? That whatever the salt particle inside that, they will come outside, and that process known as crystallization. Understood or not? So solute, I can write solute plus solvent. What I will get? I will get solution, right? This process known as dissolution. And when you come back, solution to solute and solvent, this process known as crystallization. Any doubt here? Any doubt here? And here solute particles are solid and solvent is liquid. So obviously solution should be liquid solution. Clear or not? Tell this thing clear or not?
Yes, sir.
Okay. Now you saw many times that if you heat sometimes salt or sugar particles or some other thing is not dissolving properly. Understood? It is not dissolving properly. So what you have to do? You have to heat it. Yes or no? You have to heat it, or you have to do other things. So first factor, what I told, nature of the solute and solvent. Nature of the solute and solvent. I told you this thing you can try in your home also. Like you took a glass of water. Okay, you took a glass of water. You put salt, table salt, and you put sugar. You have to check that who will dissolve faster. So you will get an observation that NaCl will dissolve faster than any sugar. Clear? NaCl will dissolve faster than any sugar. Or else you take water. Do you know naphthalene balls? Naphthalene balls you saw, right?
Yes.
So you crush the naphthalene ball. It will same look like NaCl. Okay. Then obviously wash your hand. Obviously, crush the naphthalene ball and try to dissolve. It will not dissolve. There is impossible. It will not dissolve. Clear? Why it will not dissolve? See, water molecule is polar or non-polar. This is grade 11, you know, from chemical bonding, all the things. Water is a polar solvent or not? So it is a polar solvent. Okay. And NaCl is an ionic compound. Ionic compound means Na plus Cl minus. Yes or no? So if Na plus Cl minus is there, so that is also a polar. So this is also a polar compound. And there is a rule called like dissolve like. Like dissolve like. What do you mean by like dissolve like? Like dissolve like means polar solute will dissolve in polar solvent. Understood? And non-polar solute will dissolve in non-polar solvent. Now, what are non-polar solvent? All the hydrocarbon non-polar solvent. For example, you take petrol, you take kerosene. All the things are called non-polar solvent. Polar solvent, water, okay, acetone. These are polar solvent. Okay, clear or not? So you take naphthalene. Naphthalene is a non-polar compound. Naphthalene is a non-polar compound. So instead of like soluble, it is not soluble in water. It is soluble in petrol or non-polar solvent. Understood the concept? Yes or no?
Yes.
Clear? So generally NaCl, this thing, all the polar compound will dissolve in polar solvent, non-polar compound will dissolve in non-polar solvent. This is the nature, how nature of the solute or solvent affect solubility. Clear or not? Tell others.
Yes.
Kirti, Asmita, tell. Is it,
Yes, sir.
is it just you have to check that it is a polar solvent or not? Next, second, effect of temperature. And this is the most important thing. Effect of temperature. Very, very, very important. I'm giving you a star question, something coming from here. In boards also coming from here. Okay. So, what is effect of temperature? Just tell me, thermodynamics. Remember thermodynamics? In grade 11, you learned
Yes, sir.
thermodynamics, enthalpy. Remember, right?
Yes, sir.
So, tell me if
Yes.
delta H is negative, then it is called as endothermic or exothermic.
Exothermic.
Exothermic. If delta H positive, then what is that?
Endothermic.
Endothermic. Now listen very. This this dissolution process, na, it can be positive, can be negative. Anything can be possible. Understood? Dissolution process can be positive, can be negative. Sometimes I am giving you an example. Uh, After adding NaCl salt, your glass become hot or cool. You have to observe that after adding salt in water, your glass become cool or hot. You have to understand. Do it today, okay? You will listen, or making some lemonade or something. Your glass will become cool. When glass will become cool means it is known as endothermic reaction. Yes or no? Endothermic means it is taking heat from other source. That's why glass become cool. And remember, if you add NaOH or HCl in it, acid in water, acid or base in water, what kind of reaction? That is exothermic reaction. Yes or no? It will get hot. Okay, in your chemistry lab also you can do NaOH, adding NaOH, or in home also baking soda, or that are very small in amount actually. Okay, but if you take washing soda, okay, like NaOH and all, if you add it in water, the taste of the vessel will become hot. Understood? So it depends that what you are adding. But generally, what happens? Solute plus solvent to solution, it should may or may not be like the delta H will be positive or negative. Now listen, if delta H positive, okay, means endothermic reaction. Acha, endothermic reaction means if I increase temperature, in chemical equilibrium, all of you learn one thing, Lee Satelier principle. है ना? Lee Satelier principle. So in a reaction, if the delta H is positive and if you increase temperature, listen, already it is giving temperature, and outside also you are giving temperature. So what will happen? It will go backside. Yes or no? So what happen? It will go backside. Okay. So if delta H positive, endothermic reaction, if you delta H sorry, delta H positive means endothermic reaction. Endothermic reaction means it will take heat, right? It will take heat, and you are giving heat. Yes or no? You are giving it. So if you are giving it, that means it will go forward. And forward means solubility will increase. Yes or no? Solubility will increase. So for delta H positive, solubility is directly proportional to temperature. Solubility directly proportional to temperature. And if delta H negative, then what will happen? Exothermic reaction. So if you increase temperature, already it is increasing, already it is giving. You are increasing again, so it will go backside. Yes or no? It will go backside. So according to Lisa Tellier principle, it will go backside. So delta H negative, exothermic. If you increase temperature, solubility will decrease. This thing very important. Understood this? Solubility will decrease. So that's why. That is the reason behind. If you mixing salt in water, if you heat it, it will automatically solubilize. Okay, but let's suppose it is not soluble. It becomes saturated solution. If you heat it, after that it will solubilize. But if you add NaOH, it will not solubilize. Understood? That's why people told that don't wash your clothes in hot water. Okay, don't wash your clothes in hot water. The detergent or something, detergent also having this kind of sodas and all. Okay, salts and all. So they will not work properly. They will not dissolve in water properly if you wash your clothes in hot water. Understood? Here or not?
Yes, sir.
So this thing very important. Solubility. What is the relation between solubility and temperature? For what? What kind of solution? Solid in liquid solution. Clear? I'm giving you example also that if you take a glass of water and if you put NaCl into it, so that is delta H in that case positive. Okay. And if you take a glass of water and if you put NaOH, in that case delta H will be negative. Every reaction, okay, delta H will be provided. Clear? Clear or not?
Yes, sir.
Achha, third, that effect of pressure. Effect of pressure. Now, tell me, solid in liquid. Okay, solid in liquid. Will they affect by any pressure? Are they compressible? Solid and liquids are compressible. Yes or no?
Yes, sir.
Solids and liquids are compressible. If I add pressure, they will compress. We can compress them. Yes or no? Only this three state of matter: solid, liquid, and gas. Only gas can compressible. Solid and liquid cannot be compressible. So if it is not compressible, so when you mixing solid and liquid, there is no effect of pressure. No effect of pressure. Remember this thing. Okay. So solid in liquid solution, no effect of pressure on their solubility. Clear?
Yes, sir.
Okay. So this is all about our solid in liquid. Now coming to gas in liquid. Now tell me before that, any doubt till now? So what we learned, that if you add solid in liquid, how they are related, how they are, the factor of solubility will be there, that the nature of the solute or solvent, that polar dissolve in polar solvent, polar non-polar dissolve in non-polar solvent. Clear? Then if delta H is positive, then directly proportional to solubility. Temperature is directly proportional to solubility. If delta H negative, temperature inversely proportional to solubility. And there is no effect on pressure. Clear?
Yes,
Clear
sir.
on? Okay. Now coming to gas. Gas. Now gas, what is the problem with gas? That gas have a particular volume, right? Gas volume can change. Okay. Gas volume can change. So here first factor is nature of solute and solvent. Nature of solute and solvent. So what are the nature? Remember what happened? That small, like if you take a glass of water or something, water, if you wanted to dissolve hydrogen, oxygen, nitrogen, they will not dissolve. Understood? They are very insoluble. That's why underwater oxygen is not there. Yes or no? Nitrogen is not there. But in air, how much oxygen, how much nitrogen, you know? Yes or no? In air is a solution. Yes or no? Air is an homogeneous solution of all the all the gases. So in that 80% nitrogen only, 20% 70% nitrogen, 20% 25% oxygen, clear, and rest hydrogen, nitrogen and all. But in water they are not there, they are very insoluble. Understood? Clear or not?
Yes, sir.
Okay. Similarly, in water, ammonia, SO2, HCl, they are highly soluble. They are highly soluble. Again, same thing. Polar soluble in polar, non-polar soluble in non-polar. See, hydrogen is a non-polar, oxygen is a non-polar, nitrogen is a non-polar, yes or no? Non-polar, polar, any doubt? You have any doubt between non-polar and polar? I can clear it. When polar will come, when heteroatoms are there, like nitrogen attached with hydrogen. So hydrogen will have electronegativity, nitrogen electronegativity more than hydrogen. So there is a polarity. But both are same, there will be no polar. Yes or no? No polarity. So that's why they are non-polar. Understood? So these are NH3, SO2, HCl, they are polar. You saw ammonia, people told that ammonia came to your eyes, you take water, it will go down. Understood? Sulfur dioxide. See, sulfur dioxide, sulfur trioxide, SO2 react with water and it will give H2SO4. So they are dissolved in water. Clear? Sorry, H2SO3. Clear? Similarly, HCl can easily dissolve. You can easily dissolve HCl gas in water. Clear? Understood?
Yes, sir.
Same thing, nature of solute and solvent. Polar dissolve in polar solvent, non-polar dissolve in non-polar solvent. That's it. Okay? Any doubt?
No, sir.
Okay. Next, next is effect of temperature. Effect of temperature. Now, remember what I told there. What I told there. In that case, solute
If
case. That depends on delta H.
Yes, sir.
That depends on delta H. Remember, always when you react gas plus solvent, when you add gas plus solvent, and it will become solution, always delta H negative. Always delta H negative. Okay. Now, if delta is negative, then solubility directly proportional to temperature or inversely proportional to temperature? Tell.
Inverse.
Inversely proportional to temperature. Okay. So remember this thing. For gas in liquid, solubility inversely proportional to temperature. Question come in boards came that write the relation between the relation or factors of temperature on solubility when gas dissolved in solvent. So MCQ also came. Okay, you have to write that solubility inversely proportional to temperature. Clear?
Yes, sir.
Okay. Now there is I'll tell that hydrogen gas, only hydrogen gas. Okay, or inert gas, all the inert gas, hydrogen gas or the inert gas. Sometimes initially solubility increase by increasing temperature slightly. Okay, not every time. When you slightly increase the temperature, the solubility will increase. Understood? For hydrogen or inert gas. But for other gases, this inversely. But when you increase very much, then it will be also inversely proportional to solubility. Okay.
Okay, sir.
Okay. Now, third one is effect of pressure. Effect of pressure. Now, what is the effect of pressure? And this is the most important. Most important. In this chapter, some important topics. This is the important one. Okay. Here you coming actual this chapter first one formula you will get. Okay. Remember solubility of gas in liquid. Solubility of gas in liquid directly proportional to pressure. Directly proportional to pressure. Okay. Clear? Now, here comes our first law called Henry's law. Henry's law. Okay. Henry proved this thing actually. So, scientist Henry told that at constant temperature, solubility, at constant temperature, solubility of a gas directly proportional to the partial pressure of the gas. Clear? Partial pressure of the gas. Clear or not?
Yes, sir.
So what does it mean? What does it mean? Let's suppose you are taking a solvent. You took a solvent, okay, and you put a gas particle here, okay, gas particle here, and here I have placed one piston. I put a piston here. So if I press it, so pressure will increase or decrease? Obviously pressure will increase. So what will happen? Pressure will increase. So what will happen? All the gas particle will force to dissolve in the solvent. Yes or no? So that's why he told this. Okay, clear? That solubility of the gas directly proportional to the partial pressure of the gas. Now remember, partial pressure of the gas, okay, partial pressure of the gas directly proportional to the mole fraction of the gas. Clear? Remember, this is the formula actually. In this formula, that partial pressure of the gas is directly proportional to the mole fraction of the gas. Clear? Mole fraction, any doubt?
No, sir.
No? Okay. Now, to remove this partial proportionality sign, we have to use partial pressure of the gas equal to Kh into mole fraction of the gas. Now, sir, what is Kh? Kh is nothing but Henry's constant. Henry's constant. Okay. Henry's constant. What is the unit of Kh? Always remember Kh unit either in atom or something, or generally it is written in torr or kilobar. Torr or kilobar. Torr means 1 torr means, hello, 1 torr means 760 torr means 1 atmosphere. Okay. And 1 bar means 1.013 atmosphere. Clear? And kilobar means 10 power 3 bar. Okay, 1 kilobar means 10 power 3 bar. Understood this thing? So what is the formula? Partial pressure of the gas is equals to Henry's constant into mole fraction of the gas. Clear or not? Tell.
Yes, sir.
Yes, sir.
In you have, all of you have mathematics, right?
Yes, sir.
What is the equation of straight line?
Y is equal to
Y equal to mx plus c, right? Asa, if I write y equal to mx, then what is this called?
Slow.
No, wrong. Y equal to mx is a equation for what? Y equal to mx. Well, you told y equal to mx plus c. Achha, what is c? Tell, what is c? Intercept, right? C is intercept. Like this is a straight line graph. This value is c, and the slope is m, right? Acha, if I tell y equal to mx only, c is 0, so then there is no intercept, so the line will go from origin. Yes or no? Line will go from origin. Yes or no? Tell.
Yes, sir.
Okay.
Yes.
Now you only wrote the equation that P of gas equal to Kh into mole fraction of gas. Yes or no? This is also look like y equal to mx. Clear or not?
yes.
So if I make a graph of pressure of gas and mole fraction of gas, then it will go straight line and through origin, and the slope of it will be this Kh. Clear or not? Tell.
Yes, sir.
Okay. Now, what is the significance of Henry's law? What is the significance? Why we are learning this? What is the significance of Henry's law? A very good significance. Okay, Henry's law and KH. First thing, first thing is it is applied to each gas independent of presence of other gas. It is Henry's law. It is applied to each gas independent of the presence of other gas. Of the presence of other gas. That means, what does it mean? Let me explain. So let's suppose this is one solution is there. Now I added two gases, gas A, gas B, and I am giving pressure in it. Remember, A will also dissolve, B will also dissolve. This pressure applied to it, both is independent. Okay, both is independent. Okay, the pressure applied to A as well as pressure applied to B. It doesn't depend that in presence of B, A will go different. Clear? Clear or not?
Yes, sir.
Okay. Next thing, that different gas have different KH value. Okay, different gas have different KH value, different KH value with same solvent, same solvent and same temperature, same temperature. For example, I am taking glass of water and I am adding carbon dioxide, and another glass of water I am adding CH4. Understood? So solvent is same, temperature same. So CH4 and CO2 having different KH value. Clear? Understood?
Yes, sir.
Now, same I am taking one glass of water. I am adding CO2. But in the other, I am taking one glass of benzene. Benzene is a solvent, non-polar solvent, and carbon dioxide also non-polar. So I am adding CO2. For this also KH different. For this also KH different. Clear? And if we change the temperature, then also KH will become different. Clear? Clear or not?
Yes, sir.
Generally remember, KH directly proportional to temperature. That means if you increase KH, temperature will increase. Clear? If you increase KH, temperature will increase. Clear?
Yes, sir.
But this is a very good question. One question is there. Okay, that the water bodies. Okay, water livings who livings in water livings, they are good in cold water than hot water. Why? They are, my question understood? Hello.
Yes, sir.
Yes, sir.
My question is that at same temperature, okay, sorry, uh, what I'm telling, water in like in waters, in different water, in hot water and cold water, okay, water livings, okay, who like where they will be more good in cold water, and why? What is the reason behind it? Okay, what is the question? Aquatic species are more comfortable in cold water than hot water. Why? Tell. Tell. Am I audible to everyone?
Yes, sir. We
Yes,
are
sir.
thinking about the reason.
Tell. Easy only. Tell.
Because usually we can't survive hot temperature. Our body is not accustomed to the way.
Not we. They are asking. Tell. What I told. Solubility. Listen. Solubility is directly proportional to temperature or inversely proportional to temperature.
Directly proportional to temperature.
Directly proportional to temperature. What is written here?
What is written here?
What is written here? Tell.
Exothermic, endothermic.
No, for gases I am talking about. Okay. So solubility inversely proportional to temperature. Yes or no? Now tell me, in cold water there will be more oxygen soluble, or hot water more oxygen soluble is there?
Cold water.
Cold water. So in cold water temperature low, that means more oxygen. Yes or no? Cold water temperature low, that means more oxygen. That's why aquatic species, not us, we cannot survive there. Okay. Why we cannot survive, that also I will tell you. Okay. So we can't survive there. So cold water oxygen is there, more oxygen than hot water. That's why aquatic species are more comfortable in cold water rather than hot water. Clear?
Yes, sir.
Okay. This is first significance. Next, next that next on one more thing. This thing understood? Any doubt? Any doubt?
No.
No, sir.
Okay. Acha. I'm giving a question. Write down the question. Question is, you know H2S? What is H2S?
Hydrogen sulfide.
Hydrogen sulfide. Very pungent smell, and it is a toxic gas. Okay, it is a toxic gas also. So you have to find out the solubility of H2S in water at STP. At STP. Okay, at STP. How much water? How much water? The solubility of 0.195 molar. 0.195 molar solution. Okay, clear? So solubility of H2S in water at STP given 0.195 molar. You have to find out what is the value of KH. Solubility given, you have to find out what is the value of KH. Go ahead. Tell. Go ahead, okay? I'm giving you a time. 5 minute giving. Let's see, you can tell on. Correct. So, can you show? Other did? Aditya, Smita. You did not understood?
Right.
Okay, listen first. So what do you mean by 0.19195 molar? So when this thing written, your mind should say that mass of mass of H2S, sorry, number of moles of H2S, moles of H2S is equals to 0.195. Yes or no? And
Yes.
mass of water is mass of water is till
1 kg.
1000 gram. Yes or no?
Yes.
So if mass of water 1000 gram, then moles of water will be 1000 divided by 18. Yes or no? So that will be around 55.5 mole. Here, around 55.5 mole. Now, what we need? How to find out KH? KH means we know pressure of gas is equals to KH into mole fraction of gas. Right? So find out first mole fraction of gas. Now, what is the pressure of gas? Pressure of gas is at STP. STP means 1 atmosphere and 273 Kelvin. Yes or no? So pressure of gas is 1 atmosphere. So 1 atmosphere means 0.987 bar. Yes or no? 1 bar means 1.013 atmosphere. So 1 atmosphere means 0.987 bar. Remember, very easy to remember, 987. Okay. 1 atmosphere means 0.987 bar. So KH is equals to what? Pressure of gas divided by mole fraction of gas. So what is the pressure of gas? 0.987. Now what is the mole fraction of the gas? Mole fraction of the gas is 0.195 divided by total moles. Total moles is 55.5 plus 0.195. So if you calculate all of them, you will get 282 bar. Clear? This is in bar and mole fraction doesn't have any unit. Clear? Understood? This calculation, see, up to this is chemistry. After this calculation, clear? You can use calculator in CBSE board exam. Okay, no issue. That's why I'm giving this kind of thing that
For real?
yeah, you can use scientific calculator up to 100 ms. 100 ms. You can ask your teachers. You can use up to 100 ms scientific calculator in CBSE exam, board exam. Okay, 100 ms. Okay, not more than that. Better to use 82 ms. No, there is no, you can't use 999 ms or 300 ms or 600 fs as other. Only allowed 100 ms. You can search it in Google also. Is allowed or not? As per I know, when I came in my time, it was allowed. Okay, now I think allowed because last year also I saw, this year also I saw it is allowed. Clear? So that's why I'm giving this kind of thing. That's how you should do in. You have scientific calculator with you. You have.
No, sir. When I Googled it now, they say it is not allowed.
No, actually CBSE exam allowed. Exam board exam allowed. In JEE or in NEET exam, there that is not allowed. I think. So. Okay, right. I have to check because this year allowed. I think because I checked. I asked one student because sometimes some answers, some question physics questions answers. Okay, questions numerical you have to do in calculator. Otherwise, problem will be. Understood, but it is allowed up to 100 ms. I think you can check with your teachers. Okay, they will tell more better. Okay, clear? Otherwise, this calculation also easy calculation. If you do this plus this will cut. Okay, this kind of calculation you should do. Understood?
Yes, sir.
Tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now what is the application of Henry's law? What is the application? What is the application of Henry's law? Clear? What is the application of Henry law? First, tell me any idea? Any idea? Where can I apply this Henry law? Tell all of you know. Three things. Henry law told three things. Okay, what is the Henry law? About pressure? Yes or no? About pressure. Like if I increase pressure, gas will dissolve more. So where we can use this? Tell, tell. Kirti, tell.
Carbonated drinks.
Right. Right in Coca-Cola, Pepsi. Okay, all are there. Carbonated drinks. Yeah, we can use in carbonated drinks. We are using there. Like your carbonated drinks is nothing but sugar water is there. Sugar water. Okay, some solution, some syrup, something is there, and inside that carbon dioxide is there. Clear? So by in high pressure, it is adding. When you press it in high pressure, carbon dioxide will dissolve in it. And also one thing understood, solubility inversely proportional to temperature. So if you decrease the temperature, that means cold drinks, we are decreasing the temperature. That's why the carbon dioxide will more dissolve in it. Understood? That is the reason. See, chemistry, all the things chemistry related to in your life, you just have to observe. Clear? Science also, whole science is related to life. You have to just observe it. Okay. Anything else? Anything else? How many of you know swimming? Raise hand. How many of you know swimming?
I was learning, sir, but I quit.
Learning means quit means what? You learn, you know or
Then
no?
I lost balance.
Lost balance. Okay. I'm asking swimming means swimming proper swimming, not swimming in bed. Okay. Proper swimming. Okay.
No, sir, proper
Swimming in
swimming.
water. Okay. Don't know. Kirti no. Aditya.
Sir, I will ask, sir.
Huh?
I don't know how to speak.
You don't know how to swim. Okay, no issue. But if you are in Chennai, you should know how to swim. Anything, anytime, anything can happen. Okay. So in that time you can't run. You have to swim. Okay. Or else you have to take help of Kirti. Okay. Kirti will take both of you in both hands. Okay. So so next is called scuba divers. Scuba divers. What happened? Listen. In water, in water, pressure is high. Yes or no? And because pressure is high, nitrogen gas will dissolve in blood. Okay. In water, nitrogen gas, when you swimming or scuba divers, when they go very down, because pressure is high, nitrogen gas will dissolve in our uh, in their body, in their blood. And because of that, when they came out, okay, when they came out, what happened? They will get bends. Okay, they will get bends. Okay, too much problem. Like they will get uh, you know very problematic, very disease. They have to too much stretch. Okay, too much stress in the head. Many things happen. Okay, so to overcome that, what nowadays scuba divers did, they took in their gas cylinder. Okay, in the oxygen tank, what they took 11% helium. Okay, and 56.2% nitrogen and 32.1% oxygen. And because of this helium, inert gas is there. Because of this helium, what happened? That nitrogen will not dissolve in your blood. Understood? Understood or not? Okay. Because of this helium, the nitrogen will not dissolve in your blood. Clear?
Yes, sir.
Okay. Next, third third thing is called like who are climbers. You know, climbers, mountain climbers. Okay, mountain climbers or who lives in high altitude. If you go to living in high altitude means I'm talking about very high altitude, minimum 2 kilometer. Okay, minimum 2 kilometer, not like here 1 kilometer or a half kilometer. No, minimum 2 kilometer. Okay, like if I talk about Mount Everest, all of you know Mount Everest, right?
Yes,
Okay,
sir.
you can see the what interviews of them. What they are telling, that when they reached Mount Everest, okay, they got dizziness. Why? What is the dizziness? They got like physically,
Oxygen.
mentally,
Oxygen very low.
physically and mentally they got very problem. Why? Because in mountain pressure is low. Yes or no? So if pressure is low, the oxygen also low. Oxygen is there. Listen, oxygen is there, but in our blood it need to be circulate. Now it need to be dissolved. Because pressure is low, oxygen cannot dissolve, and because of that, tissue, okay, blood cell, blood cell, okay, they will blood tissue, they will get stretched. They will get stretched, and because of that, people become mentally ill or physically ill, and this is known as anoxia. This is known as anoxia. Very important. In your exam, can ask what is anoxia. What is the reason behind it? What do you have to write? That who that mountain climbers or high altitude climbers, okay, or who are living in high altitude, due to low pressure, due to low pressure, the solubility of oxygen in their blood get the solubility of oxygen in their blood got decreased. Understood? Who are living in high altitude, the solubility of oxygen in blood get decreased due to low pressure. Okay, and because of that, they will become mentally unstable or physically unstable, and that thing is known as anoxia. Okay, clear?
Yes,
One thing you can add, that we know that due to low pressure, we know that pressure is directly proportional to that solubility according to Henry's law. pressure is directly proportional to solubility. So who are climbers and all? Next thing, clear?
Yes, sir.
Yes.
Okay. Now, now these are all the application of Henry's law. Now, what are the limitation of Henry law? Where Henry law is not applicable? Limitation of Henry's law. Limitations of Henry's law. Now, what are the limitations of Henry law? Listen, there are 4 limitations I am telling. First is, if pressure of the gas is very high, okay, is very high, then not applicable. Understood? Then Henry's law not applicable. Clear? Like in space, it is not applicable. Clear? Next, if temperature is very low, then also not applicable. Clear? Okay. Third, the gas you are using, if it is reactive gas, if it is do reaction, okay, if it is involved in reaction or chemical change, gas involved in reaction, then also this is not applicable. Clear? Clear? And fourth case, if gas gets dissociation, or gas gets association. For example, you are taking a gas, let's suppose, what gas you can take? Let's suppose NH4Cl. Okay, let's suppose gaseous NH4Cl we are taking. Generally, it is liquid. Okay, so if it is after dissolving, it is breaking out into NH4 plus and Cl minus. Then it is not applicable. The Henry law is not applicable. Clear?
Okay.
Or else it is associating. For example, benzoic acid is there, or acidic acid or formic acid is there. Any acid, CH3CO2H. Okay, CH3CO2H. This is acidic acid. Another side, CH3CO2H. Just a second. Okay. So here another CO2, CH3CO2H, if I take double bond O, CH3. So what will happen? They will associate each other. This also we will learn again. Associate each other. So they will make dimer. Understood? So for this case also, Henry law not applicable, because Henry law depends on mole fraction. Yes or no? Mole fraction. You are taking 1 mole, but it is acting as half mole. So how the mole fraction is possible? Understood? So mole fraction you cannot get properly. So that's why it is not applicable. Okay. So these are the cases where Henry's law are not applicable. Any doubt?
No, sir.
Okay. Very good. So I'm giving you a question. Let's see you can do or not.
Sir, can you give example for temperature is very low?
Temperature very low means, see, if you are making temperature very low, almost the gas will become liquid. Understood? In that case, Henry's law not applicable. Okay, low means around below minus 30 degrees Celsius. Understood?
Yes.
Very low temperature is not possible. Okay. As one question I'm giving, it came in CBSE. It came in CBSE 2025. Okay. Do it honestly. Right? Easy question. Easy question. Little bit lengthy question. Lengthy means in terms of calculation. So question is KH of CO2 given. Okay, KH of CO2 given 1.67 into 10 power 8 Pascal. Okay, at 298 Kelvin. Clear? What do you have to calculate? Calculate the quantity of CO2. Quantity of CO2 in 500 ml. In 500 ml of soda water. Of soda water when packed under 2.5 atmosphere CO2 pressure, okay, carbon dioxide pressure at 298 Kelvin, okay. So find out. Okay, one more thing, remember, 1 atmosphere is equals to 1.01 into 10 power 5 Pascal. I'm giving you a little bit time, okay, take 6 minutes. Understood the question? K is given. You need to find out quantity of CO2 in 500 ml of soda water. Okay. Clear?
Yes.
Yes.
When it is depend on 2.5 atmosphere. So pressure also given. K is given. Now you have to find out. Go ahead.